Okay, so welcome to the Ludi tutorial. I'm Cameron Browne, and I'll be giving this tutorial in conjunction with Matthew Stephenson. We're both researchers on the digital ludeme project at Maastricht University. So this talk will be done in two parts. The first part is a demonstration of the Ludi general game system, how it works, how to use it. I'll just start with a brief introduction, and then Matthew will give a more involved practical demonstration of the system's features and how to use them. The second part of this tutorial will be more interactive. We'll invite participants to do some exercises and to tackle some challenges with Ludi just to get familiar with the system. And for the second part, we'll be joined by Eric Piet and Dennis Somers, who are both team members. They can help answer questions about using the system. So Ludi is a general game system for playing, analysing and generating games. So game generation could involve optimising existing games to find better rule sets, reconstructing partial games from evidence that we have, or evolving entirely new rule sets for games. So there are many ways to generate games. The system is written in Java, and we had a public release in July. Ludi supports a range of games. We essentially need it to support the full range of board games played by humans. So we have support for 0-player games or simulations, 1-player games or puzzles, 2-player adversarial games, or multiplayer games up to 16 players. Ludi supports discrete turn-based games, real-time, simultaneous. It supports stochastic elements, hidden information, cooperative games, and so on. We're developing Ludi as part of the Digital Ludeme project. This is a 5-year research project funded by the European Research Council and run at Maastricht University. And the aim of this project is to digitally model, reconstruct, and map the world's traditional strategy games. And Ludi is the tool that will do this modeling. So the aim of the project is to define the 1,000 most important traditional strategy games throughout history in a single consistent digital format. So we'll be looking at games from the start of prehistory 4,500 years ago up to the modern day. And we'll also be including a lot of modern games for comparison. So we currently have about 300 games implemented in the Ludi language. These can be seen on our library page at the URL shown. The way we're modelling games is by decomposing games into their component ludemes, which are essentially game memes or units of game-related information. So these are like the building blocks of games, and they encapsulate key game concepts. For example, here we have a game described in ludemic form. You can see that the game has 2 players. The equipment includes a board, which is a square grid of 3, 2 types of pieces. The game is played by adding a piece to an empty cell per turn, and the game ends if a player makes a line of 3, in which case they win the game. So even without knowing this language or having seen it before, most people will recognise this as tic-tac-toe. So this ludemic way of describing games is very, very simple, but also very powerful. And I believe this is the only way that we could describe the full range of games required for the Digital Ludeme project. The compilation process for turning these descriptions into actual playable games is starting with the game description. We call these .lud files. These are just text descriptions compatible with the Ludi grammar. We pass this through an expander that expands any macros in the description, such as defines and options to produce a string. Then we parse the string to create a token tree and match each keyword in the description to the corresponding Java class. Then we pass this token tree to the compiler, which assembles these classes into executable bytecode ready to play. And I'll point out that the compiler is very forgiving. given a token tree, it will compile a game any way it can. So generally, it's much safer to catch any errors in the game description at the parser stage. So this should make more sense after Matthew's demonstration of the system. So the Ludi team consists of myself leading the project, Matthew, who works mostly on the GUI and the networking side of things, Eric Piet, working on the game logic. He's here today. If you have any questions about how to phrase certain rules in the game language, Eric's the person to ask. Dennis Somers is our PhD candidate working on the AIs for Ludi and feature learning. If you have any questions about the AI, Dennis is here as well. He's your man. And Walter Christ is the anthropologist on the project, advising us on the historical aspects of which games we need to model, how to model them correctly, and what evidence we should be dealing with. Okay, so this concludes the introduction. I'll pass you over to Matthew now for a more practical demonstration of Ludi and how it works.
Okay, thanks, Cameron. I will... Okay, can you all see the screen I'm sharing? You can hear me? Okay, great. So yes, so I'm going to now give a bit of a demonstration of the Ludi application itself that Cameron just talked about, and show off some of the things that you can do in Ludi. Okay, so this is the Ludi application here. This is the main view that you will be seeing if you use the application most of the time. On the left, you can see we have this game board where the pieces are placed and where the majority of the game will be played. Near the top right, you can see we have some information about the players of the game. So here we have things like the ordering of the players, their color, if they're humans, if they're AI. If you're playing a game where you maybe have some pieces or cards or something in your hand, these will be displayed here. If you have scores or money, it's a betting game, this will also be displayed up here. And then below that, we have several tabs for showing things like the status of the game. If you're doing any analysis, the results will be displayed here. The ludeme description of the game, I'll get into those a bit later. Rules and other information, and those are displayed down here. So these are the three main sections of the Ludi view. Okay, but how do you actually play the games in Ludi? Well, here I have loaded up chess. Hopefully this is a game most of you are familiar with. And so to make moves in this game, I can simply drag the pieces around, or I can select one and then select where I want it to go. So it's a really nice, simple user interface for playing the games. You can see now that I've made some moves, these moves will be displayed in the Moves tab, so you can see what's been done. Some other useful features, we have a lot of useful features up here in the menu at the top. I don't have time to explain them all now, but later on you'll have a chance to experiment with these and try them out. So two really nice ones are showing the legal moves and showing the last move. So with this, you can see for games where perhaps you're not familiar exactly with the rules, where you can move your pieces. And you can also see the last move that was made. And we have a bunch of nice user interface features like this to help you play the games. We also have some buttons down the bottom here to go back moves. So you can go back to a previous game state. You can do all sorts of stuff like this. Really nice interface things to make just playing the games really straightforward and simple. Okay, we also can do random moves. So if you just want to make a random move, we have options for that. I can do a complete random playout to the end of the game. Okay, if you're interested in changing graphical settings as well, you can do things for everything from changing the player color. You can make some really hideous color combinations if you wish. I think we'll go back to default. You can change the style of the pieces. You can change the names of the players. You can turn on animations. You can turn on sound effects, or a bunch of user interface features and options to play around with, and to really make Ludi as easy to use as possible, and to really tailor the game playing experience to your own personal preferences. Okay. We also have network play now. This is something we added quite recently in Ludi. You can now play games in Ludi, any game in Ludi online with other Ludi users from all over the world. So hopefully in a bit, in some of the exercises that we get onto later, you can create an online game, one of your favorite games, and play with another one of the attendees of this tutorial. Okay, so I've shown you chess, but maybe you want to see another game we have in Ludi. Given the venue of this conference, shogi was perhaps might have been a better choice. So we have shogi in Ludi. We also have Zangi, which is like a Chinese variant of chess. And you can see this game, unlike the previous ones, you actually play on the vertices of the board, not the cells. So we fully support games like this. Another game where you play on the vertices could be Go. We have Go in Ludi. I'll just turn off the possible moves. There we go. So we have Go in Ludi. And for Go, we actually have something we support for several of our games is these options. So for a lot of our games, we have options here to change things like the board size, maybe the scoring system, the winning rules, that sort of thing. So for Go, we have options for changing the size of the board. So in addition to the 300 games we currently have in Ludi, a lot of them have different options for giving different ways of playing the game as well. Okay, we also have games with more than 2 players. So Chinese checkers, for example, is a game played with 6 players. And I think we actually recently added a game with 16 players. So we support some quite nice big games. 16 players, you need a lot of people to play that one. It's quite a big game. We also support games with scores. So Reversi, for example, is a scoring game where the person with the most points at the end wins. So if I do a random play out of that game, we can see here that player 2 won with 34 points. Arima is a good example of a game where you have pieces in your hand. So the board starts empty, but up here on the top right, you can see we have these pieces for each player. So this game, players initially place their pieces on the board in whatever position they want, and then the game proceeds after that. So you can see here, it's possible to drag your pieces from the hand onto the board. Royal Game of is a famous-ish historical game as part of the project. And this is a game that's played with dice. It actually has these binary dice that are used to play it, so 0 or 1. And the roll of these dice determine how your pieces move. So we support that in Ludi. This game also has tracks. If I turn one of them on, so your pieces move around the board in a predefined path. You could think of Snakes and Ladders would be another good example. Your pieces follow a path on the board. So we support things like that in Ludi. That's completely fine. So I'm only allowed to move here with the white piece. We also have a lot of Mancala games. If you know about those, these are a popular game in Africa. There are hundreds, if not thousands, of different Mancala games, and we have a lot of them supported in the system. So if you're into them, we have quite a few options. Alaska is a game that it's kind of like drafts, but you actually stack the pieces on top of each other when you capture them. So if I do a random play out here, you can see that we have these sorts of stacks of pieces. So we support stacking of pieces in Ludi. Santorini is another popular modern game that involves stacking pieces on top of each other. And we support that in Ludi as well. So you can see, as I'm going through all these, there are a lot of different game mechanics that are supported within Ludi. You can mix and match them together. For example, backgammon, another really popular game. This game involves dice. It also involves stacks of pieces, and it involves tracks that the pieces move around. So there are lots of different game elements that can easily be combined into one game. We also support simultaneous games. So rock, paper, scissors, it's not the most exciting game, but it's a simultaneous example that we all probably know. So simultaneous games are also supported in Ludi. And Danjano is an interesting game because it's not actually played on a board. You actually play this game with sort of tiles of pieces that you place on the table, and you try and form interconnected connections of pieces. So this game actually doesn't have a board. It just simply grows as it needs to suit the pieces as you place them. So we support games like that, even games without a board. You can just play on the table essentially. We also support games with hidden information. L'Attaque is a game that's very similar to the modern game Stratego, if anyone's aware of that game. And this game actually has hidden information. Players set up their pieces one at a time without the other player knowing. And then once the game actually begins, some of your pieces may be hidden from the opponent. So only there's only partial information in this game. We also support a wide variety of different board shapes and designs. Kensington is a game that has a non-regular board. You can see this board has hexagons, it has triangles, it has squares. And so we support a wide range of different board tilings and board shapes for some of the more non-uniform board designs. We also support puzzles. Sudoku is one puzzle we support. We also support several others, and we're working on adding more types of puzzles in the future. So these sorts of things, one-player games essentially, are perfectly possible within Ludi. We also have games like Theseus and the Minotaur, where it's just one player again. I take control of this Spartan soldier, and I have to avoid this Minotaur that moves automatically following a predefined set of rules. So this is again supported in Ludi, no problem. We also support what is it? Game of Life. We also support simulations such as the Game of Life right now. These are still work in progress. We're still just experimenting with adding more simulations, but we do have some basic simulations like the Game of Life in place in Ludi. And I guess I'll finish with Taikyoku Shogi, which is a variation of shogi from the 16th century around there, I believe, played by Buddhist monks. And this game is quite large. I think the board has over 1,000 spaces on it. You have 800 different pieces per player. So here, this is quite, you can't even see the descriptions of some of these pieces. They're so tiny. It's, if you know how to play this game or you want to learn how to play this game, good luck to you. It's really quite complex. Okay, so those are just some of the games we have in Ludi. I've shown you some of the features in Ludi. You can see how it's quite nice to play the game, but I'll go from Taikyoku Shogi to maybe something a bit simpler. Let's go to tic-tac-toe, tone it down a bit. So I'm hoping most of you know how to play tic-tac-toe. You basically make a line of 3 pieces and you win, as Cameron said before. But I want to talk more about the game's ludeme description that Cameron briefly mentioned. So I will actually open our description for tic-tac-toe. We have a built-in editor in Ludi, so you can modify these game descriptions on the fly and just compile them and see if they work. So this is our description for tic-tac-toe in the ludeme game description language. So to give a bit more detail, every game essentially has 5 parts. The first part is the name of the game. That's pretty straightforward, hopefully. The second part is the number of players in the game. So this is tic-tac-toe is played 2 players. So we say players 2, nice and straightforward. The third part is the mode of the game. And this is used for cases like simultaneous games. For regular alternating turn games where one player takes a turn and the other player takes their turn, you actually don't need to specify this. So for tic-tac-toe, we don't worry about the mode. The fourth thing is the equipment. So for tic-tac-toe, we have 3 pieces of equipment: a board, a square board of size 3, a disc piece that belongs to player 1, and a cross piece that belongs to player 2. And you can see that within the equipment, we have these curly brackets, these curly braces. These are used to contain sets of ludemes together. So if you have several pieces of equipment, you use these curly brackets to contain them. And the last thing is the rules of the game, the real meat of the game in a way. And the rules of the game can be split again into 3 different types of rules. You have the starting rules, which are the rules that are carried out before the game actually begins. Tic-tac-toe doesn't have any starting rules. The board starts completely empty. But for example, chess, the starting rules would contain you placing your pieces on the board in the initial setup for chess. So that's what would go in the starting rules. The playing rules for the game, which is how the game actually proceeds and plays, and the ending rules for the game, which is the condition under which the game ends and what happens as a result of that. So for the play rules for tic-tac-toe, when it's your turn, you need to make a move. What type of move are you doing? You're adding a piece. What type of piece are you adding? Well, we don't actually say here, because we specified up above that disc belongs to player 1 and cross belongs to P2. So we know which piece to be adding. You're adding a piece that belongs to you. But we could say here something else. We could say add some other piece, a cow, or something like that. If I'd specified up here a different piece, I could say down here, I want to add that piece. But by default, it's just your own player's piece. And what are you adding? Where are you adding this piece to? Well, you're adding it to the set of all empty sites. i.e. any site that is empty on the board, you can add the piece to there. You cannot add the piece to a space where a player has already played. You cannot play on top of another piece. You have to play on an empty site. And so that's basically, that's the rules of tic-tac-toe. You play to an empty site with your piece. And how do you win the game? How does the game end? Well, the game ends if there is a line of 3 pieces. And what happens if there is a line of 3 pieces? The result of the game is that the mover, i.e. the player who just played, wins the game. And that's it. And that's the description of tic-tac-toe. It's really easy for me to change some small things about it. If I wanted the game to be on a 4x4 board, I would just change square 3 here to square 4 and click compile. And we have exactly the same game, but now it's on a size 4 board. If I don't want to play with crosses, I want to play with cows, like I mentioned before. Just have to change that. Compile the game, and now player 2 is playing with these cow pieces. Okay, but you can see here that it's really simple to take this game description, make a few changes, and get something completely different. So let's see what we can actually, if we can make a new game from taking tic-tac-toe and just making a few small changes. Okay, so first thing I want to do is let's go back to what we had at the start. Let's go back to our actual tic-tac-toe description. Okay, so we have the description of tic-tac-toe. The first thing I want to do is I'm going to change this board. It's no longer going to be a square board of size 3. Let's do a hex board of size 5. So there we go. We now have a hexagonal board of size 5 that we're playing on. All the rules and the pieces and all that is exactly the same. Okay, what I also want is if I start playing on this board, you can see these crosses don't look terribly nice in the hexagon shapes. So I think I might change them a bit. Instead of having a disc for P1 and a cross for P2, what I'm actually going to do is I'm going to make both players use the disc. And what you can see here is that player 1 and player 2 are now both using the same piece. So we can actually do a little shortcut. Instead of saying that both players have to use a disc, we can just say each player uses a disc. So this is just a little shortcut to make the game description a bit nicer, to say each player plays with a disc piece. Okay. And you know what? A new friend of mine has just come and he wants to play as well. So let's add an extra player. Let's make it 3 players, not 2. Great. Now we have tic-tac-toe played on this board with 3 players. Nice and simple. Okay, and the last thing I want to do is I want to actually change this ending condition. I'm going to separate this out onto a few new lines just to make it easier for you to see. So our current ending condition is that if we have a line of 3, the game ends and the mover wins. Okay, but line of 3 seems a bit easy on the board this size. Let's make it a line of 4. So you need a line of 4 to win. Okay, great. But I also want to add another ending condition now. So I'm going to say if you make a line of 4, you win. But if you make a line of 3, you lose the game. Okay, and because I now have 2 ending conditions, I need to do what I mentioned before and put them inside curly braces. Because now we have a set of ending conditions, not just one thing. So it's just a little semantic thing. But basically, you can see here, we now have 2 ending conditions. Compile the game. And there we go. So we have this board, players take turns adding pieces. If you make a line of 4, you win. If you make a line of 3, you lose. And this is no longer the game of tic-tac-toe. This is actually the completely separate game called Havannah, which is another completely unique game published, taken from tic-tac-toe. We can get that game just by making a few slight changes. So you can see how it's really easy in Ludi to go from a game that's one game to another just by changing a few small things in the game description. Okay, let's see if we can make another game. So first thing I'm going to do is I'm going to make the board a little bit bigger. Okay, we now have an 8x8 hexagonal board, and I'm only going to change the ending conditions. So I'm going to, instead of having several ending conditions, there's still only one ending condition. So let's say the game ends if put an or here because the game ends if any of these things happen. So the game ends if you manage to make a loop of your pieces, which is the syntax is loop. The game also ends if you manage to make a connection between 3 sides of the board, not including the corners. So if you manage to make a connected chain of your pieces between any three of the board's sides, not including the corners, then the game also ends. The last rule is that if you manage to connect two corners, the game ends. Oh, that might not compile because I haven't said what actually happens if you do that. So if you do any of those things, result, so the mover wins. Okay. Should compile. Yes, great. Okay. So this is no longer the game of Havannah. This is actually, again, an entirely new game called Havannah, which is another popular modern board game. And in this game, it's the same as Havannah. It's just on a bigger board. I've just made the board 8 instead of 5. And I've just changed the ending condition. So now the game ends if you manage to make a loop, or you manage to connect 3 sides, not including the corners, or you manage to connect 2 corners. And if you do that, you win the game. So you can see from this that it's really easy to take a game description, just modify a few small things, and you get an entirely new game. So if you're wanting to create your own game in Ludi, as we'll give you the opportunities to in a few minutes, it's really easy to take a game that you know is kind of close, it's kind of similar to the game you want to create, and just change a few things, and you'll pretty much get the game you want, or at least you'll get a lot closer. Okay, one last thing I want to explain, just for people who want to go and look at the games later on. The game Go. Okay, this is another deep game, but reasonably simple rules. So if you look at the actual full game description for Go, you might be a bit confused because all I showed you before was actually the game logic description, but the actual .lud files that we have for these games often contain a lot of other things. At the top of the lud file, we sometimes have what we call defines, which are basically, they work kind of like functions in a general coding programming sense, where we essentially just assign a snippet of game description to a particular term. So here we've defined that a piece has freedom as this bit of game description here, that if the count of the liberties is greater than 0. And so anytime we would want to use this in our game description, we can just use the term has freedom instead. So it's just a little shortcut to prevent code duplication. Then below that, we have the actual game description for Go itself. So you can see, like the tic-tac-toe example, we have the players for Go, 2 players. We have the equipment for Go, you have a board, and each player plays with balls. We have the rules for the game. There's a meta rule that you can have no repetitions, so no repeated states in Go. And to play the game, you add one of your pieces to an empty site. Then you capture any pieces that you've surrounded. This here is referring to a define that we used above, assuming that after your move, the piece has freedom. And you can also pass and go. And then the game ends once both players have passed, and you calculate the scores. So that's sort of the main game description section. Below that, we have some options for the game. So as I mentioned before, Go, we have several options for board size, and these are described here. And then below that, we have metadata about the game. So this includes just generic information like a description, the rules, where we got them from, that sort of thing, as well as things like graphics and AI. So just if you go to look at a Lud description later, it's important that you don't get confused when there's a lot of stuff. You can basically ignore the metadata down the bottom. You can just look at the main game description. Okay, so the last thing I wanted to show is some of the AI we have in Ludi and what the AI in Ludi can currently do. So I'm going to load up the game Hex. Here we have the game Hex. Basically in this game, players add pieces of their color, with the goal being to form a connected chain of pieces between the 2 colors on the board. So if I do a random play out, oh, it's quite a complex one. Player 1 seems to have won this game. I'll see if I can find the chain of pieces. Yes, here you can see that player 1 has formed this connected chain of pieces across the board. Okay, so quite a straightforward game, but I'm going to actually set up some AI to play the game. Up here on the top right with the players, you can select several different AI techniques. So let's do UCT versus MC grave. And I'll give them a few more seconds to think so you can actually see them making their moves. So, oh, sorry, I clicked this play button down here in the bottom to say AIs go, start playing the game, and the AIs will begin playing. And one really nice feature that we have is we actually have this AI distribution setting. And if you turn that on, you can actually see visually how the AI techniques are thinking about their moves. So you can see these dots forming on the board at each possible place where the AI could make a move. The size of the dot indicates how much the AI is thinking about making that move. And the color of the dot indicates whether the AI thinks it's a good or a bad move. So if it's a larger dot, it's thinking about it more. And if it's a blue dot, it thinks it's a good move. If it's a red dot, it thinks it's a bad move. And so you can see from the distribution of these dots how the different AIs are thinking. So UCT, which is the red player, you can see that when they're thinking, their dots are kind of all over the place. There's like big dots all over the board. It's thinking about all the spots. But MC Grave really focuses in on the one move that it knows is good straight away. And it looks like MC Grave is actually going to win this game. So I might restart and try again, just so you can see. So yeah, at the start of the game, both players aren't really sure who's going to win. The dots are mostly purple. It's kind of even at this point. But MC Grave really focuses in on the moves that it wants to make, and UCT is kind of all over the place with its moves a bit. So this is just a nice visualization tool to see how the AI is thinking, and I will be referring back to this in later parts. I'll just show another example in chess, for example. You don't add pieces here, so they're not dots, they're arrows, but the same principle holds. The color of the arrow indicates whether it thinks it's good or bad, and the size, the thickness of the arrow indicates how much it's thinking about it. And unfortunately, our algorithms are not so good at chess. Alpha beta is a much better technique for playing chess. So maybe later on you can try that out and try your strength against alpha beta. Okay, so I want to go to some slides now very quickly. Okay, can you see the slides? It's okay?
Yes, it's good.
Okay, cool, great. Okay, so I want to show a couple of case studies of why this sort of game analysis is really quite useful for the work that we're doing and how it can help you as well in creating your own games. So this is the game Muturi, shown here in these pictures. It's basically like a wheel sort of shaped board with these stones that you play on it. It's a Maori game from New Zealand in around the 18th century. And to play this game, players take turns moving a piece of their color to an adjacent empty point, with the goal being that a player wins if the opponent is blocked from moving. So you can see in this bottom right game representation here that if it was black's turn, black is unable to move any of their pieces to an adjacent empty point, so they would lose the game. And there's a third rule that you can only move to the center spot on the board with a piece that's adjacent to an enemy piece. So in this representation here, you see these two purple arrows. These are the only two pieces that can move to the center because they are adjacent to an enemy piece. So 3 fairly straightforward, simple rules. But while it may seem trivial on the surface, this third rule that you can only move to the center if adjacent to an enemy piece is actually really crucial to the game. It's a really key rule. And in 1987, a survey of this game that was conducted, 2 different historical accounts of this game actually omitted this rule. They just focused on the first 2. They're like, that third one's a bit, don't worry about that one. But if you ignore this rule, the game ends after 1 move. The white player can immediately win the game straight away. And I can show you this in Ludi. I'll go back to it. So we can load up the game, Muturi. And I'm going to select the simple rules for the game. So this is the variant of the game where they forgot that third crucial rule. So you can just move your piece to an adjacent spot. Doesn't matter. Okay. I still have my same agents from before. Let's go. White's thinking. Oh, it's won the game. So white can immediately move either of these 2 pieces to the center and win the game. Okay. And I'm sure if any of you played this for a few minutes, you would have figured this out. You don't need Ludi to tell you this. But you can see for more complex cases how this could be really useful. And I say most of you would have figured this out, but unfortunately, this was obviously not the case for these 2 historical accounts. And even the simplest of analysis would have completely revealed this problem. So a bit of a more complex case study is for the game of Nifltafl, or sometimes it's called Viking chess. And this is a game from Scandinavia and around the 18th century dating back to. No rules for this game were ever found. But in 1732, this guy, Linnaeus, saw Tableau, which was quite a similar game. He saw that being played by some people, and he wrote the rules that they were using down in Latin. Almost 100 years later, Smith translated these rules from Latin into English. And then another 100 years later, Murray published these rules in his book, History of Chess. And since that point, these have sort of become the de facto rules of how people play the game. But unfortunately, once again, Smith made an incorrect translation when he translated the rules from Latin to English. He actually made a mistake regarding the king capture rule. And what was originally in Latin known as likewise the king was unfortunately mistranslated into except the king. And so in the original rules, this king piece here, this white piece, can be captured by flanking it with enemy pieces on both sides. So if you get a piece on either side of the king, two pieces on either side of the king, essentially flanking it, you capture the king. But in the mistranslated rules, you actually had to surround the king on all four sides. And this made the king much harder to capture. But thankfully, Ludi can help us to detect some unbalanced rule sets. Actually, back to the Muturi example really quickly, we actually have this evaluation dialogue in Ludi as well. So you don't have to just look at the AI and see how they play from these arrows. We actually have some ways of conducting automatic evaluations using the AI. So I'm going to set some very weak AI on this Muturi example and set it to go, and we can see what happens. And here in the analysis tab, we can see straight away that player one has a 100% win rate. Again, what we already knew, that player one could just win the game immediately. And therefore, the balance of the game is pretty low. But if I try out the complete rules for the game, so this is now with the third critical rule, and I run our analysis again, we can actually see what the results are this time. So now I've included that third rule that you can only move to the center if you're adjacent. This analysis actually takes a little bit longer because you can't win the game immediately. So it might just take a few seconds. While it's doing that, I can actually run the AI on this game too. So you can kind of see what happens while we do the analysis. You can kind of visually see. So with the complete rules of Muturi, the game doesn't end immediately. So that's a good sign. And with two reasonably strong AI, the result is actually that the game will go on forever. So you sort of get these loops of moves where two equally skilled players will just keep trading positions backwards and forwards, and the game won't actually end. I may have accidentally canceled the analysis when I did that, but basically, oh no, there we go, it's coming just now. So you can see here that, again, the draw likelihood with the new version of Muturi is about 90%, equal win rates for both players, because obviously the game is a draw. So yeah, it's a toss-up between a game that goes on forever and a game that ends immediately. And we think the game that goes on forever is perhaps a little bit better because two differently skilled players, the skilled player could probably beat the less skilled player some of the time. Okay, sorry, I should have mentioned that before going back to the Nifltafl example. Okay, but back to Nifltafl, we can do this same analysis for Muturi. Muturi was quite a simple case. We can do the same thing on Ludi for these two different rule sets, the original and then the mistranslated. So using the same analysis that I just showed you on the Linnaeus original rule sets for the game, the attacker and defender win about 50% of the time each. So this is quite with reasonably skilled AI. So this is quite a nicely balanced game. With the mistranslated rules, the attacker has a much harder time winning. You know, the king, you have to surround it on all four sides now to capture it. This is a lot harder. So the attacker really has a much tougher time winning this game. And again, I can show you this in Ludi. So we obviously have the game, Nifltafl in Ludi, here it is. And if I let's use the common rules. So these are the rules that were mistranslated. Oh, wait, hold on. Oh. Sorry, 1 second. Forgot to change the AI. Okay, there we go. So these are the mistranslated rules, and you can see that the white player, the player in the center, all his arrows are blue because he knows, hey, my king is really hard to capture. You're not going to do it. And red thinks the opposite. It's like, well, I can't really find any way to capture this king. You know, I have to try him on all 4 sides. This is really hard. But if I swap back to the original rules for the game, you can see now that the colors of the arrows are much more purple. The game is a lot more sort of balanced between the 2 sides. So this sort of AI visualization is a really nice way of seeing how the AI is thinking and sort of getting a rough general idea in your own head of whether the game's balanced or not. But we also have this full evaluation dialogue of metrics where you can run the game, you can see how many times it ends in a draw, how long the games last, is the game fair for both players? And so that's something in the exercises later on we would encourage you to test out if you're interested in that sort of thing. Load up your game, load in some AI. Do you think the game is balanced? What does Ludi think about this? And so if you're designing a game as well, this is a really nice tool to have. Does the game you have just made, is it balanced? Does it have some crucial flaw where the first player can just win in 2 moves? So Ludi can really help to automatically detect and identify these sorts of weaknesses. Okay, I think I'm pretty much done with the demo. I think we will now let you try Ludi out for yourselves. So we would ask you to please download Ludi and try it out for yourself. You can download it from the URL that I've put here, ludi.games/download. It does require Java installed to run it. So if you don't have that, we also have some instructions on how to install Java. We also have a bunch of other resources, things like a user guide, a language reference. We have tutorials to help you get started. And so I'll actually go to the website now myself and show you. This is the Ludi website I was saying, ludi.games. And if you go to the downloads page, we have here right at the top a link to download Ludi. So like I said, please go there now, download it, try it out. Let us know what you think. After the questions, we'll bring up a couple of exercises that can help you sort of get started. You can also find here the user guide. That's a really good reference for just starting out using Ludi. If you really want to get into the language of Ludi itself, we have a language reference. Like I said before, we have some tutorials, some examples for running AI, access to all the game descriptions of every game that we have. The website as well. This website has a bunch of other good things. So we have, as Karen mentioned before, a full games library page. So you can see pictures and descriptions of all the games that we currently have in Ludi for easy reference. It's really good if you're making your own game to try and find one that's kind of similar to that and then sort of modify that a little bit rather than starting from scratch. We also have features like a world map. We have a forum for asking questions on there. You can sign up for a Ludi account, which enables you to play online network games. But we'll get into that in a few minutes, I think, with the exercises. I think we'll take a few minutes break now for you to download Ludi and set that up. And just go back to the slide. And we can take any questions you may have right now, I think. Okay, someone's asking about the decisiveness, duration, and final score metrics in the evaluation. I kind of glossed over those. So I'll go back to Ludi and let's go back to Muturi for this example. And so yes, in the evaluation dialog here, you can specify a bunch of things. You can say how many trials you want to do, how many repeats of the game. Obviously, the more trials you run, the more accurate your results. The maximum number of the turns for that game, you want to set this to something that's kind of the upper limit so that you don't, these trials eventually end at some point and we say, okay, this game has lasted 200 turns, let's cut it off now. You can specify different agent strengths. The stronger the AI, the longer your evaluation will take, but the more accurate the result for high strength players. We also have these 3 metrics over here. We will be adding more in the future, but right now we just have balance, decisiveness, and duration. So balance is bias, basically. It's how balanced is the game. A higher balance value, the more evenly player 1 and player 2 won. So the example I showed before, where player 1 wins just first turn, will have a really low balance because player one just always wins. It's not a very balanced game. Decisiveness is a measure of how much the game ends in a decided winner. So essentially how drawish is the game would be the opposite of that. If the game always ends in a draw, sure, this is balanced, but it's not exactly very decisive. It's not probably a very fun game. So this is a metric for that. And you can tweak the weights for all these things. Perhaps you don't care so much about decisiveness. You can move that down. And then duration is a measure of how long the game lasts. If you want your game to last for a specific number of turns, maybe you want the game to end roughly after about 30 turns, you can set this value down here, and you can specify a particular range for the number of turns you think the game should last, and then the duration will assess the game based on those values. So I can click evaluate here.
Yeah, I'll just add, for the duration, we do allow an automatic calculation based on the branching factor of the game. So it's a bit of a fudge. It seems to work for most cases, but that will require further investigation to fine-tune the calculation for what is an optimal game length.
Duration, at the moment, we do have this automatic calculation, but it can also be set just based on your own personal preference. Balance and decisiveness are the two main ones. And then once you click evaluate, oops, minimized it, you will get some results like this. So we have metrics for things like the draw likelihood, how much the game ended in a draw, how many times it timed out, i.e. how many times you reached the upper turn limit, the average number of moves per game, the win rates for each player, and then the values for each of the metrics based on the weight that you set. And then a final score, which basically just sums them all up. Someone asked if it's possible to run Ludi on the game via the command line. Yes, it is. I would suggest you talk to Dennis Summers for more about this, but yes, it's perfectly possible to run everything from the command line. We do a lot of experiments ourselves with the AI and with Ludi. We have some tutorials on setting that. Dennis, I don't know if you want to say any more about that.
Yeah, so we have like a programmatic API. Yeah, you can run games from the command line. We've been using that a lot ourselves for like training our AIs and evaluating trained AIs and those sorts of experiments. So that's possible. I also saw a follow-up question about saving the trials. That's also possible. So if you play these games, you can save them. We don't save the states. We only save the actions that were played, but those are sufficient to just replay them again.
Yeah, so that was for the question about saving a log of the game. And
yes,
we don't save the states. We simply save, we sort of have the initial state, and then we have the moves to reach any of the intermediary states of the game.
Okay, good. So yeah, actually, I was just wondering, is it possible to use Ludi to detect some impossible winning conditions? I will take an example, the same example as Mike Cooks in his tutorial. Imagine a tic-tac-toe on a 3x3 grid, and the winning condition is 4 in a row, which is impossible. So is it possible to detect this kind of flows?
I can imagine that we can detect it sort of through, like, probabilistically, through just sheer trying the game out many times. But are you meaning more sort of, can we tell from the game description itself that this would be impossible to ever achieve, rather than just running agents a lot of times?
Yeah.
Okay.
The answer
Cameron?
is no, I think. Yeah, the language is getting quite complex. We have about 400 ludemes and about 600 enum constants that can be used in different combinations. Just the complexity of trying to disprove certain conditions, I don't think that's going to be feasible.
Okay.
We do have a full game tree expansion. So for really simple games, you could do something like that. Like for tic-tac-toe, you can create the full game tree and then therefore know that it is actually impossible. But yeah.
All right. Okay. Thanks. And if I may, I have a second question. I'm just looking at the ludems for the Go. Yeah. First, actually, I don't see the macros that you show on your presentation, and in the editor, I don't see them. You know,
we have two options for the editor. We have editor packed and editor expanded. The expanded is just we've taken the defines and expanded them into the game description. If you understand.
Right.
So
yeah, indeed.
So expanded is like we've done some sort of combining of the defines. The packed is like what's literally written in the .lud text file.
All right, yeah. So now indeed in the packed, I see them.
Yes.
No, actually my question is, how can you take into account the different rules for Go or for other games? Like for Go, you have Japanese rules, Chinese rules, which is not the same way to count points. So how can you really handle that?
Do you want me to take this one, Cameron? Or okay, I will. So for Go, we have options already for the board size. So we would essentially do the same thing for those. I think, Eric, Cameron, do you know any games we have with different ending rules in the options?
Ludus Latrunculorum would be a good example.
So here you can still see what I'm showing with Ludi. You can.
Yeah.
So okay, cool. Here we have a bunch of different rule sets for the game with different ending rules. So let's see. That might be a bit big. Eric, do you know a simpler one? I know for example, hex. We have two variants of the rules for hex, the ending rules, a misery version and a regular version. So here, for example, these are the ending rules. When you see this sort of red angled brackets in the game description, that means we're using an option to replace that. So for hex here, you can see there's one for the board size, and we also have one for the result of the game. So this is a really simple example where we just swap win and loss, basically. But for Go, we would have essentially the same thing. We would have an option probably replacing the whole ending condition. And then down in the options, we would have the ending condition for Chinese with whatever scoring system that was, a different one for the Japanese rules, and that sort of thing.
Okay.
Yeah, I'd say that our Go implementation isn't complete so far. I think we've implemented the Chinese rules, but we will do the options for Japanese and Korean rules, also the starting positions for handicaps.
Yeah, I think right now it's Japanese rules, but yeah, right.
But yeah, essentially we have that part at the end with the scores. You can essentially take that out, put that in one option, do it again for a different option and change whatever values you need, change the COMI, all that sort of stuff.
Okay, yeah, looks simple to do indeed. Right. Okay, thanks.
You have two possible ways in that you can define the different options to define the different kind of rules for each possibility. And with the rule set mechanism we have, you can define a set of options to run all this set of options in one time, in one click. So Matthew, maybe you can show a rule set maybe directly with Ludus.
For Ludus?
Yeah.
Okay. So yeah, for Ludus, we have also, instead of options, we have these rule sets, what we call, which are essentially just combinations of several options put together. So if for the different versions of Go, maybe they have different scoring systems, but also something else was different, you can combine several options together into one rule set. The Ludus one is a bit big, so maybe Eric, you know a good spot to sort of go to that?
This is a big one.
Yeah, we have a lot of rule sets for Ludus. I don't know if we have some simpler case, maybe like Senate or something.
But it's okay. I mean, you answered my question, and
Okay,
I
great.
see that you have other questions in the chat.
Oh,
so I
yeah,
don't want to monopolize. Right. Thank you, guys.
No worries. In the same way, the must feed rule for Mancala games. You know what that is, Eric or Walter? I don't know much about Mancala games, unfortunately. The person in chat, do you know a Mancala game that has this rule? We might have it, and I could load it up. Or you can download Ludi and see yourself.
I'm Pierluca. I asked the question. He's asking if you make a move that basically will exhaust the opponent, and so will basically make him lose without any pieces. He will basically says, don't do that rule. So in some variation, there is this rule. It's a kind of generosity. You don't steal all the seed from the opponent to and make him starve. Okay, because that's mainly about starvation. Mancala.
Sounds familiar, Eric. You?
Yeah. For our that I think
it's very difficult for me to implement it. Well, when you implement it in code, it's actually very difficult. So I was wondering whether you were able to implement that in your Mancala, Because that would be very interesting.
Yeah. I think for overlay we have something like that. You cannot make a move if the opponent have no legal move in the next turn. So in reality, you have to feed the other opponent. Yeah. So yes, we have a kind of filter. So you define your different move, what you can do, and on it, if you do it in the next turn, so you can see here in the description, if afterwards, if the next player have at least one seed on his territory.
Okay, it's actually very easy.
Yeah.
Nice. Thank you.
Okay, thanks.
Yeah, regarding the question about multiple end conditions from Michael, no, we don't provide that facility yet to measure the ratio of end conditions that are triggered, but that would be useful to measure, and that's something we can do. We can log which rule or ludeme is triggered for each move and for each end condition. So that's something we should add. Yep. Regarding the question from Hiroki about how did we decide which rules to define as keywords, that essentially came down to a lot of trial and error. We went through a few iterations of how to define the rules, and we found the best mode was to have a smaller number of what we call super ludemes, verbs like is, not, can, count, and so on, and then parameterize those. So it makes the descriptions more consistent and easier to read, but gives us a huge amount of flexibility. We can easily change these parameters into different combinations.
The keywords.
So yeah.
Sorry.
For example, we have is line, or is connected, or is tree, or is path, but all with the same basic format.
We have a list of keywords you can find in the Ludi language reference, also available on the download page. And we list there all the keywords if you want to see them, but we still would advise if you're making your own game, just take from an existing one and modify some stuff. Someone asked in the chat if the AI should be developed in Java with a specific AI.
Yeah, so currently we have a Java interface.
API, sorry.
Yeah, so currently we have an interface in Java that you can implement, and that's definitely the easiest way to implement your AI. We do hope to eventually provide like a Python API or something like that, and technically it would already be possible if you do all the work of implementing this communication between the languages yourself. But for the future, we hope to facilitate that a bit more. But right now, the easiest way is definitely just in Java. And then you've got like a standard API just with simple functions to like, we just call a function if we want your AI to select a move, and then we tell you how much time you have, and then you can just use that time and return a move.
We also provide example AIs based on like UCT and that sort of thing that you can get the source code of and build upon or insert your own algorithm there, where we've sort of done all the framework around it for you already.
Yeah, sorry, I might jump in and just do a quick demo of the board designs we have. Can you see the screen I'm sharing?
Yep.
Okay, this is a semi-regular tiling 33434. So the description is very simple. This is just this tiling size 2. So for each side, we have 2 major elements. And we can apply various operators, such as taking the dual. So here's the same tiling enlarged to size 5. And we have the dual, which is the Cairo tiling. This is a very nice board for games. And I'll show you another feature of the editor. If we look at any element, we can right click on it. And this brings up alternative ludemes or enums that can replace that token, and with any help from the Java doc for the Java class that's available. So here we have the different types of of elements we can replace it with. So I've never seen this board before, but it looks like an interesting game board. 3464 is also a nice board. This is the board, it's a rhombi trihexahedral tiling that you'll find on the Kensington board. It has quite some nice properties. The jewel is not so interesting. But as you can see, it's very simple to explore different tilings with Ludi. The jewel is a very powerful operation, and we have essentially an opposite operation called subdivide, which takes the cells and subdivides cells of a certain size into subcells. So we can create quite a variety of boards very simply.
But we have some exercises that we think, we've come up with some exercises that we think might be good for helping you get started using Ludi. Obviously, because Ludi has so many different things you can do. You can play games with it, you can design games with it, you can analyze games, try out AI, all this sort of stuff. We've come up with a series of exercises that you can sort of tailor what you want to do with Ludi and just pick those that are most relevant to you. So if you want to just play games in Ludi, we would recommend that you download Ludi and try playing against some of our AI, see if you can beat them. And also, if you'd like to play against other attendees of this tutorial, you can create a Ludi account. There are instructions in the PDF. Sorry, I should mention here. This link here will take you to our exercises PDF, ludi.games/cog2020.pdf. And in that PDF, we have instructions on how to make a Ludi account, how to play online against other attendees here. So that might be something nice to try out. If you want to create games in Ludi, we have a tutorial. Again, links provided in the exercise document for creating the game Amazons completely from scratch. So you can sort of step through that process. We explain all the different aspects of the game description again to help you sort of get started. But if you want to leap right in and try tinkering with the game descriptions yourself, you can use the editor in the Ludi application to try modifying some of the existing game descriptions to give new spins on them. Like I did before with tic-tac-toe, I was able to create brand new games just by changing the board size, changing the ending condition, all this sort of thing. So feel free to have a play around. If you have any questions, just ask in the chat or ask us with voice and we'll try to help. And if you're wanting to analyze games in Ludi, if you like that sort of aspect, the evaluation, we provide some simple game examples of some simple games played with just stones and sticks in the dirt, where we sometimes don't know the rules for these games. And so we have suggested some possible reconstructions for some of them. What do you think of these games? Are they fun to play? You know, for the Muturi example, can you immediately win the game? That's probably not great. Can you improve the rules in the game in some way? You could try this outside of Ludi first, just playing with yourself. And then we have those games also in Ludi for you to try and improve. I think, yes. So as always, feel free to ask us any questions. Feedback is always welcome. And we'll have some Ludi challenges coming up later for people who want something a bit more difficult. But for now, I think please download Ludi, please try the exercises, pick those that are most interesting to you, and we'll be here to answer any questions that you have, anything at all.
We've got a new question in the chat. Do you support any commercial games like Blockers, Carcassonne, Settlers of Catan, etc.?
Yes, we support some commercial games. We have some of the GIPF games, and we will have the full range of GIPF games. The Ludi interface is not well suited to the more complex modern board games. So we tend to prefer games with one board plus components.
I think some of those games could theoretically work. Carcassonne is quite similar to the game Tracks, which we have in Ludi right now. It's not exactly the same, but it's kind of like that. Blockers we could definitely do. That's kind of similar to the L game, I think. I'm sorry, I'm not exactly specific on the rules of these games. I just conceptually they kind of look similar. Settlers of Catan would be quite complex.
Yeah, there is also the issue of permissions. We would have to get permission from the publisher for each of these games, which can be difficult.
We do have, but yes, we do have some commercial games that already exist in Ludi, like Cameron said. Santorini, I know we have. Some others as well. You can, our library page is a really good way to search for specific games on the ludi.games website, because you have pictures there of all of them. Send them privately.
One quick question maybe. Do you have some compilation errors? If I do something, you know, stupid and impossible and try to compile it doesn't work, but can it explain me where the error is?
Yeah, in the status panel, you should see an error message that tries to pinpoint where the error is and what the error is.
Okay.
And also, if you're in the editor window, there's a little dot at the top right. If your game parses, that will be green. If it doesn't parse, it will be red. So before you press the compile button, it's always good to check that you've got a green dot for the current description.
Yeah, right. Yes, indeed.
And another little aid is we have bracket coloring. So odd even brackets are light blue, dark blue, just to help you match up the brackets. That's one of the hardest things with these descriptions, is getting the brackets right.
So Drax is another tile game, so similar to Andantino or Carcassonne, as someone mentioned before. So you have these two designs of tiles, and when you place them, you have to make it so that the colors sort of line up with each other. So I will oh, the game is already over. Oh, that was quick. Too easy. I may have biased the initial setup.
So for the AIs, maybe you can show that you can also always select Ludi AI instead of selecting.
Yes. If you're not exactly familiar with these different techniques, we have the first option under human is Ludi AI. Here we will automatically select what we think from our analysis is the best AI for this game. So if you don't know what flat MC, UCT, MC grade, all this stuff means, just select the Ludi AI to play against. I was going to say we also have games where you play on the edges. I don't know if I mentioned this before, but in dots and boxes, you sort of, well, I'm playing against the AI. I hope I win. You add edges to the board essentially to create these regions of space that if you manage to fill, blue already got that regency. I think blue's just going to destroy me. Okay, yeah. So we support games on edges as well. I don't think I mentioned that before. By real-time progression, you mean like real time, like with ticks and stuff? We are currently working on that. It's not fully supported yet within the system, but the game of life is essentially like that, because essentially we can just make moves every, we have a timer in place. Yes. Okay. Yeah. So yeah, so for example, game of life, currently I can click play and that will just run in real time. We are working on improving this up to several players, and that's something. This is currently just a simulation where essentially you have to make a move within a certain time point, and if you don't, you just pass or something like this. But this may...
If we speak about the current version online, we don't have real time like you can think about it. So just that kind of simulation, this is something we hope to support later.
Yeah, so the intention was that we would eventually support simple video games with real time. Tetris is a classic example, though that is a lower priority since the project is really about historical board games, but it's something we hope to add.
We sometimes have some alternating turn versions of classical board games like Tron. So essentially here you play like in the normal Tron, but you take turns. So something like this we could easily take, and well, not easily, but we hopefully in the future can take and add a real-time aspect to it to sort of force a player move after a certain period of time.
if you go to our website, Ludii.games, on the games page that's there, we have a list of all of the games that are in our database currently. Any of the ones that say awaiting reconstruction, we have we do not have a complete rule set for them, and no one has kind of made one up either. So those ones are definitely games that we have no idea how they were played. But basically any game from, I would say before 1500 generally has a lot of questionable rules. So they fall under this category where they're just poorly understood, and we only know certain pieces of what might have been the rules. So that's going to be the basis for our reconstruction. But even more games that were played more recently, where say an anthropologist has gone to Africa or somewhere and described a game, but they did it incompletely. So we have several of these. I can't think of any off the top of my head, but where people have described the rules very briefly, and we can kind of know generally what the game is about, but there are major holes in how it was played because the description was poor. So there are all these kinds of different scenarios that we're dealing with for our reconstructions.
This is an interesting case. This is a game board that was recently uncovered and dated to 375 AD. It was found in the tomb of a Germanic chieftain. And all we have is this broken board and a few pieces. So this is the typical task that we have to face. This is what Ludi is largely designed for, to take these the partial evidence of what we know about a game and to find rules that this game may have been played with. So with Ludi, we know pretty certainly what the board size is. It's not sure whether it was 15 or 16 columns high. We're pretty sure there are pieces of 2 colors, but the pieces may also be 2 sizes. So given this equipment, we can search over rules that were known to have been used around the same time and in the same places to devise plausible rule sets for how this game might have been played. And that's one of the benefits of the ludemic approach. We can decompose games into their component parts, and if an aspect, a rule, a piece of equipment is not known, we can just slot in ludemes that may have been used. Generally, it's assumed that the balanced game is the better design, like the games that survive through the centuries tend to be the balanced games. Though there are entire categories of asymmetric games, like the hunt games, like Nefertafel, where the king aims to escape while the opposing force tries to pin them in. So sometimes balance isn't critical, but in general, that's one of the key factors in deciding whether a game survives. Balance, decisiveness, you want games to produce a result more often than not. There are many of these simple games that are subject to cycles where if players make optimal moves, they just make the same move patterns ad infinitum. So we have to add new rules to stop these cycles. Typically, we forbid repeating a board state. The other key factor is the length of the game. This is tied in with the decisiveness. So these are the 3 factors that we measure with Ludi at the moment. These are quite concrete and easy to measure. But to evaluate reconstructions for how likely humans are to have played them, there are many other aspects. Some of them we can't measure. The depth of the game is very important, the uncertainty of the game. Many games introduce a chance element, such as dice, spinners, and so on, to bring in this uncertainty. Whereas the more complex games, the uncertainty is inherent in the horizon to which players can see ahead. So these are all the factors we're trying to bring into our measurements. Then it's up to the historians to use Ludi as a tool to look for the criteria they want and to decide which reconstructions were probably more plausible than others.
If I could just add a little bit to that, Cameron. We also, so in the question, we kind of understand that there might be cultural differences between these kinds of different measurements that we're going to be using. And because we're going to have 1,000 games when we do it, and we're going to have several games from, from all regions of the world, we could potentially do some kind of analysis to see what kinds of lengths of games or bias are, bias in games and all these kinds of things are typical for different times and places. And then for our reconstructions, we could kind of gear our reconstructions to have a result that's similar to what's in those places. So there are ways to kind of address the cultural side of it rather than expecting a game to be what we expect from it now.
Yeah, and in many of these cases, there are always exceptions. For example, some of the Mancala games, they're played more as a social event rather than a game that players try to win. The game of Bow, I believe, can go for hours or days where players get bored, they leave, another player steps in to take their place. So it's almost a performance. These things we can't really measure. So the reconstructions will have to be done on a case-by-case basis.
Okay, Dennis, are you able to answer the question in the chat?
Yes, so there's a question about if the agents, like AI agents, have to be implemented in a specific language or not. So implementing them in Java is definitely the easiest option. We provide a standard API, like an interface that you can just implement with basic functions. So we have a function that we call if we think that your AI should return an action, and we give you the game state, etc. So that's definitely the easiest way. We hope to provide a Python interface in the future. If you want to use your own favorite language right now, you would also have to implement the communication between your language and Java yourself. So that's not an easy option right now, but it would technically be possible. Yeah, so right now Java is definitely the easiest option for that. Yeah, and I see you mentioned communicating between different programs, like if Ludi can just send the states or the moves. So the issue with that is we support like 300 really different games right now. And it's very difficult to come up with a standard format, definitely for the states, but also for the moves, because there are very many different types of moves. So it's difficult to come up with a single format that works for all of these 300 games. We would like to look into that as well, but it's really difficult to find a single format that works for every single game. So that's the main issue there.
Yeah, so for some games, we have rotation of the pieces. It's another feature we support. Employ, you're allowed to move a piece. And then, well, maybe not rotate that one. I don't know the exact rules. You can rotate some of the pieces. Another thing we do for rotation, I will show briefly, is L-game. In this game, you have these much larger pieces. So these are pieces that cover multiple cells. And in this game, you can also rotate them around and slip them in where you need to. Another feature we also support in Ludi.
I think for a modern game, Ringo is one. I think we have it in. for the commercial one. And also we have a kind of 3D games we score for, if you want to show it.
I'll see after this game, I suppose. I don't know how to play these games.
Yeah, this is a modern game. This was released a couple of years ago. This is a game we had to contact the publisher and the designer for permission.
What was the other game, Eric?
Score 4.
Score 4. Ooh.
I think this is also a modern game, I'm not sure.
Matthew, in the chat, someone asked about showing the source code of some really simple AIs. So I put a link in the chat. Maybe
You want me to
you
open
can
that?
just go there and screenshot.
Let me see if I can share.
So this is just the source code for an example random AI. So obviously that's the easiest AI that we have. And there you see the most important function, the select action function. And well, it's a random AI, so that's very simple. But the same repository also has an example implementation of UCT, and also an example implementation of a decoupled UCT for simultaneous move games. And those are obviously a bit more complicated than just a random AI.
Someone asked, for games that involve chance, in the analysis, do you have a measurement of the ratio between chance and skill?
No, we don't, not yet.
Not currently.
We will. Yeah, Hiroyuki Aida is looking at the concept of noble uncertainty, the idea being that uncertainty in a game is the key to that game being of interest. Once a game is decided, players lose interest. So we will be looking at ways of measuring this through both the chance elements and also through basically the skill horizon of the game, how far ahead players can plan. So for more complex games, there's an inherent amount of uncertainty just because the games are so complex to play. But that is work we will do shortly.
I think depending on the game, if the game obviously does involve some sort of stochastic element, we can detect that. And then how much that plays a factor in the game could be decided by comparing AIs of different skill levels. So you would expect that in a game where chance does not play much of a role, that a skilled player could beat a less skilled player a lot of the time. If the game was heavily chance-based, like, take the extreme, snakes and ladders, a game that is purely 100% chance-based, no matter how skilled you are or how weak you are, the game is 100% chance-based. The ratio of winnings between the two agents would be 50-50. So looking at the comparison of these, the difference in performance between a skilled and weak AI maybe gives an indication of that. I'm sure there are several ways that this could be tried to be analyzed.
And Irving Finkel, he's a curator of the British Museum who's studied a lot about ancient board games. He has a theory that the balance of chance and skill is critical to a game's survival. He pointed out that the earlier predecessors of what were probably backgammon like the Royal Game of Ur, they had reasonably close chance and skill, but with the chance being, say, 60% to 40% ratio. But when backgammon came along, this ratio became much closer to 50% each, and therefore backgammon, it overtook these earlier games and survived through the centuries.
We had a different question in the chat asking for documentation on the command line. So we don't have a lot of documentation right now on the command line options. We also don't have a lot of command line options anyway. We just have a few that I think just the ones that I used personally for like training AIs, etc. But you can get some help info if you just run the command line with just -h or ~help. Then you get some information on those command line options. But alternatively, if you're looking to run experiments using Ludi yourself, I would recommend not directly using the command line, but writing your own code if you want to set up your own experiments, so you have full control over them, and just using the Ludi jar file as a library for your own source code. And for this kind of programmatic use, we do have some tutorials, so I linked to one of them, but you can find other ones there as well.
So I should just give a little bit of an explanation. This is a game, Spline, where you play on a 4x4 board of holes, essentially, with these balls, these sort of billiard balls. And once you create this bottom layer, you actually start stacking the pieces on top of each other to sort of create this sort of pyramid-like shape.
You win if you make a line of the size of the level where you place your ball. So for the ground, a line of 4, for the second level, a line of 3, etc.
So you can see here that I think Black is pretty confident in him winning. Let's see, his moves are all blue. Let's see if he's correct. Yes, he was.
Not true.
I will briefly just mention, because I alluded to them before, that we also, as well as the exercises, hopefully people are finding those okay. If you have any questions, please let us know. Goodbye. On that same document, the same exercises document, we also have some challenges for if you really want to try doing some more complex things with Ludi. We've come up with some design challenges for you to have a go at. These might be a bit too difficult for you to attempt now, but if you want to get into Ludi and you try these out, please email us your Lud files or post on the forum. We're happy to help outside of this tutorial in the future. So we came up with these two Ludi challenges. Essentially, we have a game design challenge where given the board and the pieces for a game, like some of the historical examples that Karen mentioned before, say we found this board in an archaeological find and we found these pieces, but we didn't find any rules for the game. So can you come up with a good set of rules for this game given just the equipment? So we have an easy and a hard example for this in the exercises and challenges PDF that we linked to before. You will find a download there which contains the game descriptions for these games with the certain parts of them missing. So for these games, we provided you with the equipment and some very simple rules, but the rules aren't very good. We need you to try and come up with new rules for the game. So here are two example board designs. The one on the left is just a board setup with the pieces there. How do you think you could make an interesting game out of this setup? You know, maybe the pieces slide around, maybe the pieces hop over each other, maybe you have to capture the enemy pieces, you have to reach a certain point. There's many possibilities. And on the right, we have a slightly harder example with a slightly more complex board. And in this one, your pieces start off the board and you add them to it. So maybe you can come up with some exciting thing for that. You can try these out by yourself and you know, with some drawings and some stones that you have to see if you can come up with some interesting rules and then implement those in Ludi. And then we have a second challenge, which is kind of like a reverse spin on that, where you are given the rules of the game this time. So in this case, for our board design challenge, you have to make an orthogonal line of 4 to win the game. So if this was the rules of how to play, what would be the best board design that would complement these rules? So I've listed down the bottom here a couple of example board shapes, that some of which we've mentioned before, that maybe leads to a really interesting game with these rules. So maybe you can try out some board designs yourself, see what the analysis thinks. Do you agree with the analysis results? Yeah, and feel free to email us what you find if you find anything interesting. We're more than happy to help anyone get started and use Ludi.
For the first challenge, you show Matthew the hard one. Maybe you can show the board directly in Ludi, symbol S.2.
Yes, can. Because yes, Eric's right. The second example is actually based on a real symbol that was found. I'm not sure exactly of the historical evidence for it, but they suspect this may be a game. So we have this symbol here that was found, and they found some stone pieces that maybe played with it. And so the rules that are for this game are completely reconstructed. We do not know exactly how this game, if it even existed, was played. So perhaps you can come up with some really interesting rules for this game on this board.
Yeah, currently in Ludii, our construction is the rules of six-man Maurice, I think.
So yeah, often we have to just take rules from other existing games and see if they work on this one. Yes, I will just briefly show. We have on the Ludi website, we have a forum where people can register, ask us questions. We're always looking on these. So if you have any question, big or small, on Ludi, any suggestions for features that you think would be really cool for us to add, that would really be nice, please do let us know.
Okay, I think that might officially conclude the tutorial. Thank you all for joining us. And please download Ludi, please play with it. We're happy to answer any questions at all. But thank you very much.